Comment video regarding the lensing thing. I mean the waves, gravitational waves. So, yeah, I made a couple mistakes. 7 milliseconds, not 7 seconds. September 14th, 2015. Yeah, okay. But anyway, not very important ones. But, no one else does this whole live thing, so whatever. Um, I'm not too worried about that. Um, so I've done some more thinking, and what people, I guess, it'll take a while for people to appreciate is what they're claiming here for the first time is really creation of push gravity. That's essentially what it is, right? I mean, gravity is known as something that's always been a pulling force that something does by bending space-time. Creates this, what ends up being a pull. And clearly this is the destruction of 3 solar masses into some kind of real force that's a pushing force. So I don't think they would argue that if this wave interacted with, well, I think they might argue. I mean, it was kind of a funny moment where she said, well, look, it passes right through all the stuff, right through the matter. Well, obviously it doesn't even pass through the matter here on Earth, because that's how you detected it, is that it didn't pass through. It reacted. The matter reacted to it. And I don't think they claim that it reacted by pulling the Earth towards the black holes. I think the argument is going to be that it pushed the Earth. So, I mean, this is an important milestone in the theories of relativity and the whole idea of space-time, is when now you're converting real matter into space-time, in a sense. I mean, it can only be looked at that way, right? I mean, this is the first time they've created push gravity, right? So it's right, and from my perspective, that's the good side. The dark side of this whole thing is, yeah, now there's more gibberish noise that I have to talk through, which just is going to make it harder and harder to do this thing, because, yeah, now everybody's just going to keep saying, oh, what about gravitational waves? Yeah. Anyway. So there have been some interesting comments posted, and so it is. There's just so much to go through here in terms of. So they get this little ziggly line. It really isn't that much information, right? And the surmises that are built into their interpretation of that signal, is really, there's a whole lot of that, right? There's a whole lot of, well, it could be, two giant, 260 solar mass, two gianter, bigger solar masses, 1.5 billion light years away, or, I mean, just the whole idea of how they conjecture their way into this description that they came up with is just that, right? It's just this process of saying, well, it can't possibly be this, but it could be that, but it could be that also. But let's go with this and then see how that takes us, and blah, 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 that kind of thing. But there really isn't enough information in the signal for them to do anything like what they did, which is say, oh yeah, there's this 26er and this 32er and blah, blah, all that kind of, no. No way. So anyway, but the idea of the southern hemisphere, I have deduced that part, where they saw it coming from, is that 7 millisecond delay between Louisiana and Washington is where they got that from. That it had to be in the south, where there's a Mexican volcano, by the way. Yeah, it would be, I did a brief search on September 14th. Apparently a lot of solar flares. There was also this little satellite event that took place the day, I guess it was the day before, where the moon and the earth, were in alignment with the sun, and that does create a little bit of, so solar flares at the same time as there's an earth-moon alignment, blah, 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 blah. Who knows, right? So many little things it could be. But yeah, it would have been nice to see more of the background material. So, I mean, that's the real problem, is we don't get to see the raw data and say, well, what exactly are you comparing this thing to? So you have a simulation of, you have you have, yeah, simulations, I guess you could say, creations of demo signals, and then they try to match the signal to the demo signals, you know, for different events. But really, I mean, I'm just saying that, you know, for nobody to, I mean, for people to say that this is probably a good way to do science, where, like I said, they really are speculating a little bit, you know, you know, like on drugs or something. I mean, it's a little bit like speculation on steroids to sit there and start describing this event in such detail from this very limited information source. Can we call it that? But anyway, I mean, you know, like I said, it's just, you know, but and the whole Einstein thing really bothers me, just because, you know, I know. Look, back in Einstein, you know, back in whatever 1916 or whatever the fuck. You know, I mean, we barely had telegraph, for fuck's sake. You know, I mean, it was so Einstein was just basically speculating that, you know, obviously we have radio waves. You know, why wouldn't you think that if you have oscillating solar bodies that they would also be creating a frequency, you know, as they wobbled about. But I don't think Einstein envisioned anything like reducing 3 solar masses into some sort of magic particle, undisclosed space-time force entity that would be expelled from this event. I don't think that was anything Einstein believed in. And, you know, there's all kinds of little, you know, the backstory is always a little messy. I mean, the truth is, Einstein in 1936 tried to publish a paper, right? The only paper that was ever rejected by a scientific publication. And of course, Einstein found that a little bit offensive, right? Einstein invented space-time, and they basically rejected his paper because they were going to tell Einstein what space-time was and tell him, no, you can't, no, you're wrong, you made a mistake. And, you know, Einstein found that a little bit offensive. And then Einstein found, yeah, he did make a mistake in his math because he was worried that he was creating singularities, and so there couldn't be gravitational waves because that would create singularities and blah 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 blah. But they were only virtual singularities. They were only artifact singularities in the math. They weren't real ones in the real world, and blah blah blah. Well, anyway, he still published, but, you know, for some reason they don't. Well, the Rosen guy he worked with published, and so they deduced that the Rosen paper is really the Einstein paper. But anyway, basically saying, no, gravitational waves can't happen. So that's kind of like, so when they talk about Einstein beaming, I don't know if Einstein would really be beaming. But anyway, I don't think Einstein bought into any of this extra stuff. Like, they've taken Einstein's space-time and they've turned it into this gigantic, monstrous thing, you know, that does all kinds of crap. And I don't think Einstein would say, oh yes, that's perfectly what I was saying about the whole falling into the black hole, and then you could go visit your grandmother at a nursing home, and you could do all kinds of things from the black hole, and you know, you shake hands through the wormholes and things, and you could touch and feel people's penises and things, and it was very interesting in there. I don't think Einstein would say any of that shit. So I'm just saying, this just sounds like a, you know, what am I supposed to say? Okay, this is what science does. This is the yammer you have to talk through. And then there's all these millions of cranks out there blaming the military-industrial complex and blah, 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 blah. So Ken Fire in the Sky he did find a nice hunk of data, background on these things. And does seem like this is all some sort of, you know, the military like this idea. So let's just say this had a dual purpose, right? Is that what they call this kind of science, dual purpose science? So that's why it was basically funded, is because they saw the dual purpose in it. You know, military applications. Alright, anyway. Which is always disappointing when you find out, oh, that's the string that was getting pulled here. Oh. So anyway. So yeah, I guess I'll do some comments. But anyway, the real point here is that you have this huge amount of energy, they say, was released in this very small amount of time, which I don't really understand that how that. I mean, this whole you know, it's like the spinning quarter. Okay, I mean, I could drop a quarter and spin it, and somehow the velocity has to be gotten rid of, right? So we're back to this whole argument about the acceleration and the velocity, and one thing has to win in the end, kind of thing. But you know, in a quarter, the quarter doesn't get eaten through the process, and the fact that, you know, it doesn't lose anything, so to speak. But somehow these black holes do. So somehow when they get to a certain point, then they just start spewing a ton of energy. And somehow it's not electromagnetic photons, they're these gravitons. That's what this is about. It's not really a story about anything unique in the sense of the gravity itself. It's what's really the weird statement here is that we see supernovas and other events, and they create common radiation in the sense that they explode, and we don't say, well, 85% of the mass that was expelled was in the form of gravitational waves. It's always been argued that 85% of the mass expelled is in the form of some kind of radiation, common photons. And so that's this unique feature here. Somehow black holes emit black radiation. So that's another subtext, I guess I would argue, is that if they were talking about two flaming suns spinning around each other, I don't think there'd be any conversation about the suns getting converted into black radiation. Yeah. I did see a future problem coming up. I mean, this sounds like when you have black holes of this limited size, you know, then you're going to start saying, you know, what do? Black dwarves? I mean, that's what you're going to have to start saying, right? These are black dwarves. They're essentially suns that are, you know, that are going through the consolidation process. But anyway, they have made this look a little too much like atomic structure and nucleuses, and I just don't think there's a justification for that. You know, like where, you know, atoms combine nucleuses, and then they expel all the extra bits. And they've sort of taken these big galactic events and saying when two big things merge, they have to necessarily expel some quantity of their essence. But again, expelling it in dark energy, which I guess you could call this shit, in a sense, it's definitely push energy. So, no, calling it a gravitational wave is just in a lot of ways misleading, I think. But anyway, so this Liber module guy says, it's obvious that the physics elite have concocted a story of gravitational waves at the same time that Emendem has cracked the case of wave theory cover up in order to stop Emendem from uncovering the great scientific lie and from unifying physics. Or whatever, I didn't read it right, or it wasn't written right, but it doesn't really matter. Just not little snarkyisms that are just so useless. So I'm going to just delete, you know, these commentaries that have nothing. You have to put some kind of evidence in your commentary that I've said something that's completely or fundamentally wrong. I mean, that you have proof that it can't possibly be correct. Otherwise, fuck this. It's just bullshit. I mean, calling me names is just of no use. And if you don't, especially if you don't have the use, call me all the names you want if you have the balls to actually make a video. But if you're just going to do this on my videos, and I don't have the same right to do it to your videos, fuck that. In a sense, a confused conflation here. Like one side of your brain wants to accept reality, but the other side refuses to back down from all those videos. So again, there's more of this psychological stuff. So again, only pedophiles have no icons, in my opinion. Okay, it's people hiding from the police. They're afraid they're going to be caught because they're pedophiles. You're a child molester, quite obviously. That's why you have to hide behind rocks. That's why you're used to hiding behind rocks, because you know you look at the little winkies through your telescope, and you know. That's the game you play in life, so that's the game you play on the internet, quite obviously. Why else would you have to be anonymous, except for the fact that you're a pedophile, for fuck's sake? All this stuff you've said and time you've committed. You've gone too far to stop now, haven't you? Well, again, I'm only becoming more and more confident every day. And, of course, the fact that they've now basically announced the existence of gravitons, 3 solar masses worth of gravitons, can only make me feel pretty good, realistically. Or have you? And the ultimate way you solve complex problems in the universe is pointing at pictures, apparently. I don't know what else you're supposed to do, but that's what they've done in their video, didn't they? In their non-Hollywood production, didn't they just point to a bunch of pictures? And I think somebody should just point out, well, you made that picture up, didn't you? Oh, you made that one up too, didn't you? Yeah, you just made that up, didn't you? Yeah. Well, this doesn't sound right. This just can't be true. I don't know. I'm saying certain things you have to question, right? So, I mean, you could even take that signal and you can say, well, there's certain rules about a positive signal, right? That this mirror vibrating, you're saying, okay, it could be pushed one way and then it's definitely going to have to swing back. I mean, it is on a pendulum. Let's understand that. So you can sort of understand, okay, I guess that's why it can go to a lower low than the noise signal, right? I mean, you have this constant noise. And so you'd kind of expect a positive signal to go above the noise, but it can't eliminate the noise. Now the fact that this new signal eliminates the noise is a little bit surprising. Now that doesn't surprise you, but it sort of surprises me. And that's a question that's asked, idiot. You just don't want this to be true. Will all your being, will all of my being. Well, if you're going to say something so bold, you might want to say it correctly. You know, and put with instead of will, but okay, whatever. All of your brain power is working to suppress any doubt that you aren't right. Again, it just doesn't even occur to me to worry about that kind of crap until some kind of real evidence pops up. And I'm just saying, in every respect, I've already detailed the whole thing has been done publicly. And you're saying I shouldn't be at all amazed that I start off with a theory of gravity, ended up finding a simple road to time dilation, then another simple road to a description of magnetism, and an explanation of inertia that's just so fucking obvious. And you're saying that somehow I shouldn't be, wow, holy shit, that all fits. And it makes sense, and I don't have to do bent space anymore, and I don't have to do wavytons. That is so cool, because I hated those things. They didn't make any sense. The fake dimension of space-time. Yes, I never felt like space-time was pushing me into the earth. It just never made any sense to sit here and say I'm being pushed into the earth by empty space and time conspiring to push me into the earth. Now that made sense to you maybe, but it never made sense to me. Let's see. It's about really bizarre shit. Well, I certainly think it could be put to better use. Well, you can think whatever you want. I think you could be put to better use as, you know, some sort of pooper scooper or something. One of those little things that you use to take cat shit out of litter boxes. I have to say, though, this announcement couldn't have come at a better time. What madness lies ahead, I wonder. I don't know. We'll have to see. But Obama will no doubt take credit for it. I found gravity waves. I killed Osama bin Laden, and I found gravity waves. Yay! That will be pretty hard to watch, right? Okay, hey, Menem, you don't have a clue what you're talking about. Science really did it. And you are insulting real science and real scientists who have made these discoveries and have been consultants on silly movies. Yeah, I'll play some of that. Yeah, it's pretty funny. You are out of your element, and I doubt that you suffer from social anxiety. Well, it's not, you know, it's not technically a social anxiety. It's just people make me throw up. So it's, you know, whatever you want to call that, that's what it is. People make me want to throw up, especially people like you. And, yeah, I prefer not to. The way you taxes these scientists, I'd probably like to throw up on them. You are on the warpath. That's right, mate. And you are fucking us. Fuck you. I'm fucking you somehow, huh? Anyway. Alright, so that's enough of the ones I deleted, because obviously there's no content. Oh, I should read half of these. Yeah, let's point out the obvious. I can do that pretty good. Alright, just watching a couple of minutes. Okay, so right there, it's just so useless to do this commenting thing after a couple of minutes thing. It just doesn't, really no point. It can be seen that Amendum does not understand the spiral picture that is being shown. Yeah, I saw a much better computer graphic, you know, where they actually had the projection went up and away from the thing spiraling, so you got the idea that it's going away. Okay, not that it's trailing behind. So I'm just saying, if they would have just drawn that animation, okay, without it being so round, because that really didn't seem quite right, you know, put a peak on it, you know, to indicate this is something moving, and then they just, you know, when the thing is spiraling, they have the stuff coming out from behind it. If they would have put the blob perpendicular to it, then you'd understand this is something it's emitting, and then have it go away at the speed of light, which would be, for every distance this goes, that thing moves away at twice the distance, right? The idea is these two things are moving half the speed of light. Well, then the speed of light would be, that thing would move away twice as fast as the rotation distance, right? So they could have made it a little bit more realistic, and they didn't. So that's not my fault. And I'm just saying I've seen better animation. So I'm just saying they used the animation that's, frankly, not a very good one. You don't get that? Okay, fuck you. I mean, it really is kind of important to give the idea that this thing is falling apart, and radiation is leaving at the speed of light, and I'm just saying that animation does not give you that impression. Alright. The gravity waves are not moving along the spiral-like ball, moving along the spiral groove as he indicates with his finger motions, and says, this is the stupidest thing I've ever seen. Shit. Well, I'm just saying it's a stupid representation of, if you're going to draw energy, that's not how you would draw it, okay? Obviously, the light doesn't come out of the back end of the sun as the sun moves. It's coming out of the side of the sun. The point is, they should have made the indication it's escaping at the speed of light away from the thing. You're telling me that's what that drawing indicates? No. First of all, the spiral's too tight. Doesn't indicate how fast that wave is disappearing. And second, they have it coming out of the back end of the thing spinning, which is retarded. It should be coming out of the side of the thing spinning. Correct? Yes, that's correct. Each tiny portion of the spiral is moving directly outward from the point where it was originally emitted. But I'm just saying the drawing has nothing to do with that. I just noticed 10 tens ups for that. So most people think that was an accurate way to describe something moving away from an event at the speed of light, even though that spiral was moving much slower than the thing spinning. Now, if you get me, the spiral was moving slower than the thing spinning. Do you get it? That can't be what light would do, right? The light would be leaving twice as fast as the thing's spinning. So it's exactly upside down. So you 10 up people, you're just proving my point, right? You don't know this. You don't understand physics, fuckers. Alright, Skid Row Ray. Good video. Certainly some major questions need to be asked. I wish reporters at the press conference had asked some of the questions you laid out here. Well, I wish they would have just at least said, how can you get so much detail? I mean, wow. I mean, you got it all described here. You're telling me what color her panties are. I mean, really, all of it. From this. I mean, how do you do that exactly? I did wonder about the computer image with the spirals. It could have been seen as an Armageddon of the points of the straight line force as described below in another comment. Yes, I'm just saying that, like I said, if you look, there's better animations, and they chose a really bad animation. I mean, it's probably their in-house one, and it sucks, frankly. It doesn't describe the reality. That's all I'm saying. So, I mean, frankly, you should be proportionally accurate, and it's not proportionally accurate. The wave is leaving twice as slowly as the things are spinning. That's not right. Okay? Okay. All right. Yeah, I had to check the calendar to see if it was April Fool's Day, too. That's kind of funny. Ken. Jesus. He's just such on another planet that he's so useless because he just has all this wacky stuff tied to his criticisms. It's like that camera guy, Angry Photography. There's just no point. I mean, he's very anti all this stuff, but the theory he's pro for is just so wacky that there's no point. I mean, it's just tragic. All right. So Numbly Numb does some pretty good. I mean, it's just he's asking the questions that need to be asked because it is kind of based on current model astronomical events, the predictions of general relativity. Gravitational waves that originate tens of millions of light years from Earth are expected to distort the 4 kilometer mirror spacing by about 10 to the minus 18 meters. Less than 1/1000th of the change in diameter of a proton. So again, these mirrors are suspended. The whole idea of doing that is to keep them from jiggling. Right, but they're supposed to move with real land movements. So slow movements they'll move with, fast movements they can't do. These seem like pretty fast movements to tell you the truth. I mean, that whole thing was happening in a quarter of a second. That seems like an awful lot of fast movement for this big giant mirror to be doing. But anyway, let's just say it does. Obviously, like I said, it does have this pendulum effect. You got to just figure that if it stretches and the Earth relaxes, that the mirror is going to swing back all the way. And that's something I just didn't like in the fact that they're using this waveform, because yeah, the peak you can understand, but the down is always going to be a little tricky because that's going to be a reflection not only of whatever signal you might have, but the fact that it's not going to know how far to swing, based on the Earth doing a little bit of this. The Earth is technically doing this, and the pendulum has to swing in some kind of harmonic to that movement. It can't really move exactly as the Earth is moving. Okay. Equivalently, this relative change in distance is probably one part of what might cause the detection would be a late stage in spiral merger of 10 solar mass black holes, not necessarily located in the Milky Way galaxy. Which is, okay, so that's off the Wikipedia page prior to this event. Something like that. Anyway, have they demonstrated they can meaningfully measure a space less than 1/1000th of the diameter of a proton? Yeah, I just don't know why they're going that. It just seems like, well, yeah, I just don't, whatever. How would they go about calibrating such a tool? Would they even dare to answer that question? I just imagine, I just would like to see all the signals they get when, like, somebody, like in Australia, they have a beer party and a bunch of people fart. I wonder if they can pick all that up. I mean, I just wonder what kind of signals they're getting from just events that are happening. Good goddamn, did he just say an instrument can measure the, the difference in length that is equivalent to one human hair over 3 1/4 light years? Yeah, he did say that, which was really quite bizarre. I mean, it just doesn't, it's on its face, it sounds like a little bit of an exaggeration. We know the sun doesn't shed its mass evenly. It sheds radiation in cyclical bursts. Yeah, which is, again, this is just so, I just don't know how this signal doesn't have a whole bunch of really loud things in it still. How do they get all the noise out? Because some of the stuff happening locally has got to make one hell of a signal. How can they rule out the sun, which is believed to shed an average of 1.66 kilometers from its surface, isn't interfering with such an unprecedentedly sensitive instrument? Yes, and again, why do we believe the sun is producing any of these positive gravity waves when it's deteriorating? I'm just curious. This is an infinitely dense black shithole of confirmation bias induced by pathological lack of skepticism. In all probability, it's fraud, and you can rest assured they're going to try to rub your nose in it every time you object to anything at all related to demented space-time. It is true. Oh, could be a false alarm. I have to read The Guardian. Science Across the Universe, 2016, January 12th. Gravitational wave detection could be a false alarm. Ooh. Oh yeah, we'll have to go read that later. That might be funny. Let's see. It could be a false alarm. Caution is needed and claims gravitational waves have been found. It could be a fake to test the detectors and scientists involved. It has been before. Could be a fake. I don't know how it could be a fake that way. I mean, they're saying somebody faked it internally to see if everybody would overreact and cause a huge press nightmare for the National Science Foundation. No, I don't think so. Alright, so we'll see. Lawrence Krauss. He's bothered by this. My earlier rumor about LOGO has been confirmed by independent sources. Stay tuned. Gravitational waves may have been discovered. Exciting. Okay, that's his tweet. So, when did he get that? Of the 11th. Shit, I knew it on the 10th. That's kind of fun. I knew it before Krauss. Shit. Thank you, whoever posted the pre-announcement. So that's kind of funny. Alright, anyway, let's get back to business here. Comments. Where are my comments? There they are. Okay. So thank you for that article. I'll read that later. Alright, a black hole that's 150 kilometers in diameter. Did they change the definition of black hole when I wasn't looking? I don't know what the definition of black holes are. Frankly, this whole idea that black holes can go anywhere from, a couple of solar masses to 1 million solar masses. I just don't get all of that. I mean, usually most of these structures can only do certain, everything is confined. You know what I mean? You don't find galaxies that are 1,000 times bigger than other galaxy kind of thing. There's a limit. I don't know whether that maybe 1,000 is the wrong word I should have used, but I don't think there are, galaxies that are 1,000 times bigger than other galaxies. There's a certain mechanism that can only maintain at a certain size, and it just seems like black holes completely break that. In the sense that they have black holes that have 1 million suns in them, and then black holes that have 30. I just don't think it works that way. But I just don't think it works that way. It doesn't, Or am I just thinking of the wrong verse in the multiverse? Yes, they're just singing the wrong tune. They're not going to want to hear. They're not going to want to hear that one. It seems like that the quantum theory, in quantum theory, the degree of imbalance in the gravitational field necessary to cause a black hole-like mass would be self-limiting due to the fact that the quantons travel in straight lines. Yeah, that's certainly my theory. I mean, this whole straight line thing gets all busted up in this mush. And how do you compress matter? I mean, there's just no evidence you can do that, right? We can't even compress electrons, for fuck's sake. I mean, I just don't know how they get rid of the regular charge problems where they talk about how strong charge is, the strong force in atoms, and yet they are going to totally annihilate it to compress matter into these little balls. When there ultimately be some kind of finite limit to how many quantons could be blocked a given moment related to the volume of the mass doing the blocking. Right, but they don't understand. They don't think there's blocking taking place. So clearly, that's what I see. I think I don't know what exactly Einstein was thinking, but clearly, I don't think he was thinking about positive gravity. And from my theory, right? It seemed plausible that you might be able to detect the blinking of the gravity. When something's spinning, it's got strong gravity, weaker gravity, strong gravity, weaker gravity, from the blocking idea. But this whole idea that, okay, this thing is shedding a quanta moving the speed of light that are not regular photons of any kind. Like I said, it just sounds like they're saying it's making gravitational pressure, and it would have to be incredibly destructive to anything near it, because this is like the entire, you know, this is like this is like all the energy of the universe in one day, you know, blipping at this location. It's a tremendous amount of energy, and you know, I just don't see how it wouldn't be making a huge vacuum around it. I mean, it would just be pushing everything anywhere around it. Everything's just going to get pushed the fuck away, and so you're going to have all kinds of accelerations and whatnot taking place. It's gravity, for fuck's sake. We know gravity moves shit. Like I said, they're detecting it because it's moving the fucking surface of the earth. How can she say it just passes through everything? It can't possibly just pass through everything. It's gravity, bitch. Anyway, all right. So this is the Ken stuff. So he goes through all this, you know, old nuclear site, this, that, the other thing, all this, whatever, blah, blah, blah. So it's sort of interesting. All right, then, stupid holiday. Correction, September 14th. I was wondering who was going to do this. You know, like, it needs to be pointed out that I got the date wrong. No. But anyway, it doesn't matter, so who cares? It was a Monday, and I felt a little queasy in my stomach. I remember it. Well, I guess holiday is as good as an interferometer. And he was detecting the space-time deflection and such. Yeah, I don't remember what I was doing that day. But like I said, there were volcanoes volcanoing. There were sunspot a sunspotting. I would like to just see a run. You know, just the typical run of this seismograph is what it is, right? It's a big seismograph. Let's not, you know. It'd be just interesting to see what a daily pile of mush from it looks like, just so you can tell how distinctive this piece of mush was based on all the other mushes. But again, so much is being told from this little tiny thing. I mean, it's just this little, you know, blip, 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 little acceleration at the end, and this is what they're saying, you know, adds up to them knowing so much detail. And I just, like I said, I think we know that's just made up. Alright, let's play some of this, whatever it is. So this is some paper I was reading on Einstein. The physical review is, you know, that's the publication that, you know, they reviewed his request for publication and just defended the fuck out of Einstein. What do you mean you're reviewing me? Fuck you. You publish it, you fucking cunts. I mean, that really was his expectation, so I sympathize. Fucking cunts. Yeah, it's these assholes. Man, what do you think, you're smarter than me, you fuckers? Fuck you. Anyway. Okay, so this is, where's the press conference? Press conference, where are you? Gravitational waves exclusive. What the hell is this? Oh, that's the one I have to read. Okay, so this is the Russian news with a very English-speaking guy. So this guy is getting to be kind of annoying. You know, he's the guy who's a consultant on the stupid movie. So, well, anyway, that's the clip here I stopped at. I just find this a little bit. I mean, you're supposed to be a professional. You're working on this scientific project, and then you take little side jobs consulting on silly movies. I don't know. That just doesn't seem right to me.
That's fiction, but how close is it to becoming fact? Is such a mission ever going to be possible, do you think?
I love this technology thing, right? They can detect gravitational waves billions of light years away, and there's like, this is like more like he's talking to some guy on the moon. There's a huge delay, you know, in getting the questions and the answers. I mean, it's just hilarious.
So I believe that humans will ultimately do missions to black holes, but the nearest black hole is much farther away than the nearest other star besides the sun. We don't have the technology to go there now. We won't have the technology to go there for several centuries, but I do believe we will get there, and we will do explorations of the vicinities of black holes.
Yeah, right. We'll get there in what? Magic ships. I mean, really. wormholes? Oh, please.
Very, very unlikely that anyone will ever go inside a black hole and survive. We're not 100% sure, and in the movie Interstellar, it does happen, and I explain in a book I wrote called The Physics of Interstellar.
Right, so you not only get a consulting fee for doing the movie, then you get more money selling a book explaining why you're not being a stupid scientist to consult on a silly idea. And so then you just concoct some, well, you know, it's possible that it may be possible that you could go there and, you know, squeeze on Tinkerbell's breast and stuff.
Explain how it happens, but that's speculative, that we don't understand the interiors of black holes well enough.
There we go. We don't understand the interior of black holes well enough. Yet you can do all this shit. You can tell me that when they merge, they splash, and then they zoom, and they wish, and they wash. So you don't understand them well enough to say whether you could live inside of one. Right? I'm sorry, but does anybody see how ludicrous this is? They're telling me what this thing was. This little jaggedy line. They can tell me what the fuck it was. It was two black holes, one 26 stars, one 36 stars, blah, 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 blah. And they can tell me all that shit, right? No problem. But they can't tell me whether I could live inside of a black hole. Your own animation has the fucking things flaming. Yeah. Jesus. Fuck.
To know whether that could really happen, it probably can't. But what we have seen today is something that in some ways is more fantastic. It's not just a black hole.
Oh, it's more fantastic. Okay, I haven't heard this part yet, but this is good. It's more fantastic than going inside a black hole and, you know, getting to third base with Tinkerbell.
There that you're studying is two black holes that go around each other, spiral together, and collide. And in that collision, they create something we have never ever seen before as humans, as scientists, as astronomers. They create a storm in the fabric of space and time.
Okay, now whatever that means, right? They create a storm in the fabric of space and time. They convert into an energy, okay? So you want to call it something else, go ahead, but, you know, it's not something else. It's quite obviously energy, because when it got to Earth, it was felt as energy. It's a positive energy. Not any of this bent space crap. Bent space could only do bent space down. It couldn't do bent space up. It wasn't supposed to be able to anyway.
You know, it's as though we had never seen the surface of the ocean on a calm day. Or we had only seen the surface of the ocean on a calm day. We had never seen it in a storm with crashing ocean waves. Similarly, we had never seen space-time with wildly oscillating rate of flow of time.
Well, again, how much it oscillates in the flow of time. And again, you're saying that somehow, well, there's no point in me going through what he's saying, right? I mean, they're taking their fake dimension, which was usually just, okay, you bend the fake dimension basically tells things where to go. And now they're conceding that this fake dimension does leak energy into the real universe.
Wildly oscillating shape of space. We had never seen that before. Now we have seen it both in computer simulations and in observations with this gravitational wave detection.
Well, again, observations, they always use these key words, right? They have a jagged line, and they're saying the jagged line is all of this stuff. That's reaching, man. That's just fucking reaching. Fat there. Fatty working on the mirror.
It's a whole new way to study the universe, a whole new way to probe aspects of black holes that we didn't understand until now.
What do you mean? You did understand them because you made simulations. So again, it's exactly like our simulation. This is a much better blah blah. See, this stuff is flying out this way instead of behind it. So it's a little better representation of what this beacon is.
Clearly, a lot of scientists are extremely excited about this.
Beacon.
Why, though, in particular? What opportunities do you foresee opening up now because of this?
So really, it's this huge positive dimple in space-time, okay, telling other matter, run away. There's a big blob of space-time coming. And why don't they just turn that into real quantons and then gravitons? Why don't they just call it what it is? Particle gravity.
This is just the very beginning. We've seen our first gravitational wave. We've seen for the first time 2 black holes.
We've seen them. The 2 black hole, again, it just, you know, we saw a jagged line. We saw the mirror move.
Colliding to form a new black hole. We've seen for the first time how space-time behaves in a storm. But it's just the beginning. We will be studying...
really, you can really sort of see the confirmation bias. I mean, if all the scientists in this group are like this guy, you know, you can just see that they're just horny for it. Just so fucking horny for it.
Observing and studying other options. We will see neutron stars made of pure nuclear matter, like the size of a very small town, spinning around and around with little mountains on their surface.
Right, little mountains, you know, Whoville, where the Whovies live, of course. You know, I mean, all this stuff. This doesn't bother anybody, right? I mean, it just sounds a little too synthetic. We can do things to matter in space that it doesn't happen anywhere else, and I'm not giving you any kind of explanation how the fuck that happens. How the fuck we pound a bunch of neutrons into a thing, and it's just neutrons, nothing else. Yeah, well, they don't like each other, but so what? They're stuck there.
Creating gravitational waves, which will enable us to explore the physics of nuclear matter. We will see black holes tear neutron stars apart. We'll see neutron stars collide. We expect to see the central
Yeah, whatever. See. We'll see all of this stuff with a little jiggly line. And the big jiggly line will mean it's a neutron star, and a little jiggly line will mean blah, blah, blah. And it's just, you know, come on. I mean, look, some of I just don't, I can't for the life of me get. I mean, there's this whole thing with galaxies, you know, I don't know, I have to go look up the evolution of galaxies, but there's this theory that, you know, galaxies are formed by these black hole thingies spinning around each other. You detecting all of those too?
Of supernova explosions. We even expect to see, hope to see gravitational waves from cosmic strings that stretch across the universe, that are thought to have been created in the birth of the universe by the expansion to cosmic scale of the...
So again, this is real speculative crap, right? So this is just, like I said, this is the way it should be done. We have this made-up idea, these stringy things, that's deduced based on the fact that, well, you know, we made up dark matter, and so now the strings connect the dark matter, you know, and
fundamental strings that are building blocks of all matter. We will be exploring these kinds of phenomena. We've only looked at gravitational waves with one wavelength, with periods of oscillations of milliseconds. There will be new gravitational...
Right, periods of oscillations of milliseconds. So like I said, these are really big things, and they're supposed to be spinning so fast that they spin in a millisecond. I mean, I can't do the math in my head, but, you know, I don't know. It just doesn't sound quite right.
Wave windows opened onto the universe with other kinds of detectors that will see completely different things. Detectors that will be flown in space and will see gravitational waves with periods of oscillation of minutes to hours. Detectors that will see periods of oscillation of months to years.
Right, but these oscillations won't be the ones leaking all of this energy, presumably, right? I mean, you can't say all of these things are leaking all of this positive gravity, so you must be detecting the negative gravity in that case, right? Yeah.
Even decades. And then gravitational waves that have periods of oscillation nearly as long as the age of the universe. We will see all of these and learn completely different aspects of the universe with them. Each of these gravitational wave windows is sort of like going from optical to X-rays to radio waves, where we see the universe, different aspects of the universe with each of those tools each of these new gravitational wave windows will teach us different things. So it's the beginning of a whole new way to explore the universe, a way that will be a big part of 21st century astronomy and cosmology.
I'm just hoping this isn't the definition of reality, but we'll see what they do with it. Sounds like a pile of crap. And like I said, just judge the source, right? I consult on movies, and then I write fantasy books about fantasy adventures inside fantasy space. That's just not too good. Alright, anyways, that's enough of that. Is there something else I need to cover here? So anyway, yeah, like I said, this doesn't really, like I said, the only part I can use here, the only part that's interesting to me is that this is a positive bump in space-time, and it's being felt as real energy, and they're calling it kind of real energy in a way. He did use the word graviton, so I just have to figure out what he meant by that. But yeah, I mean, it moves the speed of light, right? And then it hits planets and makes them jiggle. That sounds like energy to me. And that's why I want to get this brought back to, is the energy. Alright, so anyway, then we can just figure out that, oh yeah, that shit was already out there. But again, you'd still, it just seems, this is another one of these coincidence things, that's all I'm saying, right? Coincidentally, the matter, the black hole matter, doesn't degrade like all the other matter. It degrades into this gravity energy. So instead of producing light or X-rays or cosmic rays or some other kind of electromagnetic photon, it's creating a graviton, that doesn't have any of those material characteristics, which is okay with me. I'm just saying that, but let's concede what that means. That means you have essentially created a real physical mechanism for gravity, and you really don't need space-time anymore, because you can just make space-time into an active ether of gravitons. So I'm just saying, it just kind of fits right in with what I'm saying. It's it doesn't do anything to disprove anything I'm arguing for. I guess that's all I'm saying. It's no threat to my theory, if understood. Like I said, I can't help what people are going to pretend it's meanings. That I can't help. So anyway, till next time and such. I really think that's enough. Right? I think I covered it. Yeah, I'll read this other paper and see what the doubts might be.